trying to make things simpler for the process of drawing standards today. Confidee are a PCB broker based in Oslo, but we have a large presence in Europe with different country managers dealing with our customers and also our suppliers in Europe and in Asia, in Asia too. So on we go. We'll start with the base of the PCB, which is the PCB material. Now, when specifying a material type, it is important to understand that different manufacturers, or all the different manufacturers, all have their own preferred types and preferences, preferred suppliers, much like we are when we're buying PCBs. So it's important that we don't just standardize and try and say, right, we want this one material for this PCB, because it may not, what may be suitable for one manufacturer is then not suitable for another. So we are condensing or reducing the amount of manufacturers available to us if we are just specifying one material type. So we highly recommend that we follow the IPC 4101 guidelines and add that note to your drawing and say for material must be in accordance with IPC, and then you choose the designation. For high TGFR4, that could be a /99, it could be a /126, but it just opens up then and it allows us to be creative with which manufacturers are suitable for this PCB. Bear in mind as well that material types from time to time go obsolete or they get upgraded. So if you have on your drawing notes that it must just be one particular material, and then this material type goes obsolete in the end, then we are back to square one and looking for different suppliers again. So highly recommended, follow your IPC guidelines. This then also could be applied to material designation. Now by this, we mean styles and types. So when you're picking a prepreg type or choosing a dielectric in your stack up, if you don't really need a particular style like 2116 or 2113, then don't specify it. Just specify your dielectric. So if you know you're going to need, say, a 0.1 millimeter dielectric between your layers 1 to 2, that is fine. You don't have to try and find a particular prepreg style to suit that. That's the same again with your core. If you want a 0.2 thick core, that is fine, specify that, but don't actually say, right, it has to be isolar, it has to be EM range of materials. Just the thickness is fine, and then the manufacturers will then have the choice to match that dielectric using their preferred material types. Manufacturers, again, have experience of what their preferred styles are. If you choose a style that is not within their comfort zone, then you may struggle, or you will find you may have EQs raised because they want to use their favorite. This then also applies with copper thicknesses and impedance control. Impedance control, talking with the dielectrics again, we will match your impedance, or we will try and match the impedance with the targets that you have given us. Add your reference layers clearly, add the target for the impedance clearly, and then we will send a proposal. We can match that. With impedance, and because of the different manufacturers, different processes, and these are obviously all vary from different manufacturer to manufacturer, you can expect some adjustments from what you have listed in your impedance table on the drawing. By that we mean you may have calculated your impedance with a 0.1 track and gap and supplied your data like that. The manufacturer might look at the copper distribution on them inner layers, or look at the prepreg types that they're going to use, and then say, actually, we think you need to slightly adjust this impedance track, or increase the gap just to make sure we're hitting that target. And as close as possible, the manufacturers want to be as right on target. So if they want 100 ohms, they want to try and hit 100 ohms. So these adjustments they are making, they would like to propose are all aimed at giving the best option for hitting that target. Again, then that takes us to copper thickness standards as well, because the copper thickness on the inners and the outer layers will have the effect on what the impedance control will be. So they will say, you know, they will work to IPC standards. If you specify a 35 micron copper thickness on the outer layers, actually allowed to IPC 6012, that can be reduced to 29.1 micron. So bear in mind that just because you specify a 35 micron outer layer thickness, it might not finish at that, but that's all allowed within IPC. And much of what we're asking for here is not actually capability for manufacturers, it's to be within IPC standards. You receive an IPC qualified board, then we are all happy then. UL markings. We see a lot of inquiries recently asking for UL markings and using UL approved materials. But not always are the markings compliant with the material, with the technology type. So in particular, flex rigids, they have to be qualified for UL. And every single stack up will have to go through some UL qualification. Because there's so many variations of flex rigid, it is not always easy to get the qualification. Qualification takes a long time. Qualification costs a lot of money. So if the manufacturers don't have a lot of demand for these flex types, they won't get the UL approval to add the markings. They will use UL approved material types, but they just don't have the qualification to add the marking. If you would like clarification of that, you can, or to make it easier on your drawing, you could say, especially for electric, we would like to use UL approved materials, and that would be enough then for a flex rigid to be, we could guarantee that the UL materials are used. PCB thickness tolerances, again within IPC standards, up to 1 millimeter, should have a tolerance of plus or minus 0.1. For thicknesses above, preferred is plus or minus 10%. And again, that isn't a manufacturer's capability. That is within IPC standards. Materials that come from the material supplier all have a tolerance too. This tolerance is generally larger. So manufacturers try and come within that to meet what is within their capability. Again, surface finishes within IPC standards, again, manufacturer's capability. So the IPC guidelines are there to be followed. They will follow them without question. If you then pick something out of the range of the IPC guidelines, that is then when you may expect to receive some EQ. If you've got no particular over thickness or under thickness requirement, there is no reason not to follow IPC. If you do require something a bit thicker, state it by all means, but just be aware then this might be an extra cost adder. It might take a bit more time, depending on what the actual requirement is, and you could expect to receive an EQ. But if you have no need or no desire to be out of IPC guidelines, then just follow those thicknesses and add them to your drawing notes. Drill tolerances. Preferred for most manufacturers on plated through hole is 0.075 millimeters. That is for plated through holes. Non-plated through holes plus or minus 0.05, and for plated slots plus or minus 0.01. I've left press fit off this. Press fit obviously is within capability of most manufacturers, requires more plating in the hole. Those tolerances can be plus or minus 0.05 millimeter. Just bear in mind that not all the holes on that board need to be press fit. So it is preferred that only the press fit holes have the smaller or the tighter tolerance, and then the rest follow a general standard as specified there. Via plugging, again, important to follow IPC 4761 standards. Different variations, whether it's be a via plug ink, whether it be plugged from one side, whether it's plugged from both sides, you will know, or should hopefully know, what is best for your assembly process. When it comes to via filling, this is more of a cost adder because it can mean holes being drilled at different stages, being plated at different stages. It could mean more copper on the surface of the PCB. It's different material. So via plugging is generally the more cost-effective version of hole filling, but it doesn't have the same properties or doesn't have the same functionality in assembly then, which is why then you will pay more for a via fill type. But again, the IPC 4761 standard has clear diagrams and dictates what is required for each one, and we can offer, or our manufacturers can offer, the full range of plugging and filling types there. Solder mask colours. Green is the standard, matte or gloss, and is better for functionality and for manufacturing in PCBs because it can be used with smaller distances between pads and smaller clearances around the pads. When you start to use different colour solder masks, this can also affect the design because they don't follow the same process as the green, or they don't have the same properties of the green, so they need larger clearances, larger dams, solder mask dams between pads. And again, if you don't need to specify anything other than green, then why bother? We've had PCBs that have been specified as black or blue, or with no real reason other than, oh, we did that to make them stand out because it looks nice. That's not really the point of what we're trying to do here. We're trying to make producible PCBs and as they're all getting more and more challenging to make, shall we say, with the technologies being raised, we're trying to make everything more standard and easier for production, easier for yields, which then in turn leads to more cost-effective solutions. Green is the standard. If we can follow green and wherever possible, keep the solder mask clearances, dams, everything should be okay there. Then just bear in mind when you use alternative colours, it could mean a change in the design for you. So just as a summary there then, because all of this is aimed at keeping manufacturing designs within capability, better yields, better pricing, better lead times. Follow the IPC standards as much as possible. Don't overcomplicate the notes by adding different material types or adding different solder mask colours if they're not really needed. Try and keep everything brief, try and keep everything clear. And then if you have additional requirements that aren't within something that has been just raised here, or something else that you feel is needed on the drawing, make a short summary. If too much goes onto the drawing, it can sometimes become overcomplicated with too much specified, and we're trying to keep it nice and tidy, nice and clear, so everything is just nice and readable and easy to understand. Following the IPC standards is key for material types, for design, for filling, and then also just for manufacturing and release. Manufacturers will work to IPC standards as much as possible, and they will hopefully give us boards that are perfectly within capability and meet the data that you have supplied. So this is the last slide from me. If there are any questions, please feel free to ask. We will take some now, and then there will be a follow-up, but I'm easily contactable either through the Confidee site or through FED. So thank you.